Okay, you guys, so we're going to do number 16. And let me try to clarify some stuff, all right? And we are leaving, some of the really, yeah, I'm recording. Shout out to Megan. Megan's a nerd. All right, she's taking calculus. There you go. So, you guys, okay, all right, we're starting to record all calculus videos. Did I record anybody's pre-calc class last year? Your class? Okay, and yours? All right. Okay, give a shout out to the world.
Hello.
Say hi, Mom.
Hi, Ruth.
This Ruth is going to be watching, right? All right, cool. Scotland forever. Free Scotland. Oh my gosh. 97. All right. All right. Oh man. Okay, so here's the deal. We're leaving some of the more conceptual ideas and we're getting into a lot of the rigorous algebra that is encountered in calculus. So your beloved algebra, here's a great example for you of what you have to learn to embrace and really learn to love. Now, there's a problem though, okay? That the conceptual stuff doesn't just leave, it's not quite as rigorous. And what you have to begin to understand is notation. Now, I said this, and we did an example on it, but for 16, it says find f prime of a. Can somebody tell me what the heck does that mean? Awesome. Excellent. This means find the derivative or the instantaneous rate of change, the slope at a given point. Okay? A lot of people ask second hour, they're like, I don't know what that means. That's Taylor, you're exactly right. Kimball, you're exactly right. That's what it means. That's what we're going to find. So if you needed to write an equation for a line tangent at a point, you'd first find f prime of a, the derivative. And then you'd use that to find the slope. So we're going to find the derivative, and this operation, so when it says you want to prime something, what it means is that you literally do this. This is the operation. That's what we're going to do to that. Okay, so it's like, what's your favorite operation? People love addition. People hate subtraction. They like multiplication. Well, not many people like to inverse sign stuff, okay? Our operation today is to do that thing, the derivative, okay? So let's work that out. F prime of A. This will not be pleasant, okay? It's somewhat painful. You need to get your brain ready for that. But I want everybody to know, I expect that by the time we get to the test, you guys are ready to do this type of problem, okay? So here we go. F prime of A is equal to the limit as h goes to 0 of, let's get it plugged in correctly. What do I do? How do I do f of A plus h? A plus h for x. So A plus h, quantity squared, plus 1, divided by what? A plus h minus 2. Minus, what is f of A? How do I get f of A? Plug in A. A squared plus 1, all divided by A minus 2. Sorry, all divided by h over 1. Oh, you're picky, Taylor. Okay, this isn't that bad. This is a complex fraction. I know it looks bad, but when we multiply it out, we'll see it take care of itself. What is going to be the common denominator? In order to simplify a complex fraction, I got to find common denominators. A plus h minus 2 times a minus 2. So I've got the limit. You got to write this down every time until you actually plug in the limit, because some people forget to plug in 0. So we multiply top and bottom by a minus 2 over a minus 2 times a plus h squared plus 1. A lot of people forget to put parentheses around both. You have to, because you got to include the 1 in that. Minus the quantity a squared plus 1 over a minus 2 times, what are we multiplying over there? Yeah. Okay, Lindell just had a heart attack when she saw this. She's like, I do not want to multiply that out. Could be a lot worse than just multiplying polynomials, right? You learned how to do that back in 10th grade. So, ain't no big thing, right? All right, here we go. Limit as h goes to 0 of a minus 2 times, let's square that out. Very good. Plus 1. Minus. Let's multiply it all out. A cubed. A squared h. 2a squared. Plus a. Plus h. Minus 2. All over. Sam, did you already do this one? You think you got it? What did I do? Oh, yeah. Okay, whatever. All right. Settle down. I'm trying to teach. Make mistakes. All right, so we got a minus 2 times a plus h minus 2 all over h over 1. I think it'd be a good time to get rid of that h on the bottom. So what do? Multiply by the reciprocal. So that means I would just put an h right there. So you see that before we plug in 0, we got to get rid of that h out of that denominator because this is a removable discontinuity. So let's make it happen. Limit h goes to 0. Distribute the top. A times a squared. Plus 2a squared h. H squared. Plus a. 2a squared. 4ah. Minus 2h squared. Minus 2. Minus a to the third. Minus a squared h. Plus 2a squared. Minus a. Hey. Smartboard just got dumb. Come on. You ready to write? Come on, Smartboard. No, it isn't. Minus 8 minus h plus 2. Bada bing, bada bam. Got it. All over. H times a minus 2. A plus h minus 2. Now, I'm a reward person. I'll tell you that right now. So I save my cashews and ice cream and caramel until after I get done grading tests. So I can like say, hey, good job, Mr. Gantz. You graded all those tests. Way to go. What? Don't laugh at me. Every time I do a woodworking project, you know, at the end you put the polyurethane on and it just explodes with color. It's like, oh yes, this was worth it. You know what I mean? So this is, math is all about rewarding you. You get to this point and now it's just joyful right now because you just cross everything off. Take this a to the third. Boom. You can even make sound effects when you do it. What else cancels? Find me something. A. Boom. Kablam. 2. Blammy. What? 2a squared. Boom. Gotcha. Zippo. Zami. Oh, I did? Well, somebody told me to. Marcus, knock it off for crying out loud. Yeah, that will combine. So I could take the minus a squared h and the positive 2a squared h, and that will make just a squared h. That's what happens, Marcus. How? Well, this was a negative a squared h and a positive 2a squared h. That made just 1a squared h. See that? All right. So we got the limit as h goes to 0. This all right. Are you guys okay with dividing the h off now? Ask the question. You got to ask. I got to hear what you're thinking. What? Say it, Megan. Oh. Okay, I have an answer for you there. Let's finish off the problem first. So we got a squared plus what? Well, I'm dividing the h off. Plus ah minus 4a minus 2h squared is 2h minus 1 all over a minus 2 times a plus h minus 2. Now, before we go any further, did you notice, you should have noticed that everything canceled in top that didn't have an h. That's a way to check to see if you've got it right. So once you get to this point, you could say, did everything cancel that didn't have an h? Everything must cancel that didn't have an h. If it didn't, you got something wrong. Question. Because if you take negative h divided by h, you get negative 1. No, not yet. Now, are you allowed to plug in 0 now? Yeah, because you don't get 0 in the denominator. So plug in 0. I get to plug in 0 for h. So what happens here? Goes away. How about here? And this one goes away. So we just plugged in 0 for h. So I found out the f prime of a is... Oh, stop the party. Check her out. All right. We're so proud of you. Here we go. Because h is 0. We let the limit we let the limit happen. We let h go to 0, and when it did, the h's went away. Yeah, this is done. But what did we find? Yes, a function you can use to find the instantaneous rate of change at any given point. So if I said write an equation for a line that's tangent at the point 1, 3, I don't even know if that's a point on the line, but what would you do? In order to write an equation for a tangent line, what two things do you need? Slope and a point on the line. So, no, I'm just making this part up. So point on the line would be 1, 3, right? How would you find the slope? Put in 1 into that. Whatever you get, that's your slope. So this is a derivative right here. It comes from another source. It came from this. Okay? It's the change of y with respect to the change of x instantaneously at any given point. It's amazing. It's beautiful. It's awesome. Okay? Now, I'm going to stop the video there because that's what we need, and you guys can be able to work, but I got to answer Megan's question first.